Hello. First of all, the title of this presentation was changed a couple of times since I proposed it. If you go to see the WarsawJS page, it's completely different from what I have here. This is because I realized that talking about such a huge topic as both functional programming and reactive programming in the same talk is impossible to do in less than 4, maybe 5 hours. So this is why I decided to limit the scope of the presentation. I also want to, these are the basics. These are the things that you absolutely have to know before attempting to understand and work with functional reactive programming. So I thought that this presentation will be introduction to the later possible presentation about functional reactive programming. Okay, so there's no way to talk about functional programming without the lesson in history, because functional programming lately seems to be gaining traction, and it's the new thing among programmers in many different languages. Well, it's not new. It's as you can see on the slide, it started rather a long time ago. Even before that, the lambda calculus, the work of Turing and Church in the 30s, we could trace the beginnings of functional programming to their work in the 30s. And what's important and what's relevant to us even today is that there was very early a split between two functional, definitely functional, groups of languages. The first, which do we have any Haskellers? Okay, guys, please don't feel shocked. I will tell something that may not sit well with you. Okay, first functional type of functional programming languages is based on ML. That's very early functional language based itself on I know what you mean, if I remember correctly. That's the name of the language. I know what you mean. From early 60s. And ML is acronym for meta language, and those languages from this family of functional programming languages are mostly or practically always statically typed with very powerful and safe type systems. They offer type inference, which means that you don't need to provide all the types you would otherwise. They are, in most cases, although they do have sometimes interpreters are being interpreted, compiled on the fly, so that it looks like they are being interpreted. They mostly are ahead of time compiled, just like C and other such languages. I listed some examples. Haskell is perhaps the most known, although I don't think that it's the most used. That's not the controversial thing yet. Okay, the second type, the second group of languages is based on Lisp. Lisp is controversial by itself, but I don't want to talk about its syntax, rather about semantics. Lisp was, from the very beginning, dynamically typed. It was reflective, which means that many language constructs, like types, or in particular even loops and conditions and things like this, were inspectable during the runtime. The Lisp and similar languages were mostly interpreted or just-in-time compiled. There are exceptions, of course. Common Lisp is some implementations of Common Lisp are examples of this, but mostly this is how it looks. So in the examples below, you can see I listed also the JavaScript language, because the core of the JavaScript language, which is dynamic, highly reflective, and lately even just-in-time compiled, fits very well with those earlier or even right now used languages. I could recommend taking a look on Clojure and, of course, Erlang if you would like to see something that's industrially useful and still functional in nature. Okay, so now this is going to be controversial. It's important to understand, because people who who use Haskell or OCaml or Rust or Scala are mostly convinced that their way of doing functional programming is the only one. It's not. The second group of languages is even older, although by a few years only, and has equally rich history and techniques that comprise the functional programming style in those in this group of languages. So we know that we don't have static typing in JavaScript. We know that JavaScript is not pure. It's not lazy by default. It's eager. And most of all, it doesn't rely on very deep mathematical knowledge to work with it. Other than the one that we need for the domain we're solving. Which means that, which would mean for some that it's definitely not functional language, but it is. I probably. Okay, so I was talking about functional programming quite a bit already, and probably I didn't mention what the heck this is. It's a style of programming that focuses on these three main tenets and two additional ones. Functional programming is largely about declarativeness. So in classical imperative style, and object orientation is in no way different from imperative style. Object orientation is not procedural, yet it is imperative. It also can be declarative in some parts, but then it's like link in the .NET land that they borrow heavily from functional world. I think I can show you an example in the code what it means that code is imperative and it's declarative. Actually, the examples of declarative languages just before showing the code in JavaScript. Other examples are makefiles or SQL queries or things like that, which describe the effect of computation that we want to get, and not a step-by-step procedure of obtaining this result. Okay. There's something here, probably. Okay. Yeah, that looks like this. I think it's not very clearly visible, but I hope it's visible enough. This first part of the code here is a classical imperative style. Everyone should recognize it. It's just a simple for loop that accumulates some results into the array, and those results are taken from another array and from properties of the objects in the other array. That's normal, and that's imperative. Now, declarative approach looks roughly like this. So we declare things that need to be done without actually doing them, and then compose those parts to make them a whole program that we want to run, and only then we run it to obtain the result. Probably, I think we will have enough time to explain what map, plug, partial mean, but this code, believe it or not, produces exactly the same results that the previous one produced. It's of course slower, although on modern GTED implementations, it may not be that important, but it's more concise, it's shorter, it's harder to make a bug, and as you can probably see, there's no way to make an off by one error in this code. Composability is a feature of functional programming that is achieved by having a small set, extremely simple interfaces, and expecting all the abstractions to follow those interfaces. In object-oriented programming, we have very many different interfaces. We define new interfaces all the time, which means that we needed to invent design patterns like bridge, mediator, adapter. Those things are largely unneeded, or at least much simpler in the functional style. Functional programming also strives for simplicity of functions. Each single function should be as simple as possible, so that it is easy to understand and easy to debug. It's actually not that hard to achieve, because in functional programming, almost everything can be turned into a function. A function that is longer than a couple of lines probably is too long in the functional style. It becomes a procedure, and it's a procedural programming smell in the functional code base. As the fourth point here, there's a preference for, because well, there are languages that there are people who would say that immutability and purity are required for the language, for the environment to be considered functional. It's not true. Closure, which supports immutability in its wide array of data structures. There's vector, list, map, and so on. Those are all immutable. Actually, is not pure, and so the same goes for scheme, which is another functional language with years and I guess decades of tradition. It doesn't even have in the standard immutable data structures at all. Both immutability and purity are nice features to have. They are not absolutely required. About purity and referential transparency, this is the same thing. I probably should mention what this thing is. I think with immutability it's not a problem, as everyone should already know what it is, but I mean, strings in JavaScript are immutable, right? So that's immutability. Purity is a characteristic of functions of or programs which says that there are no side effects which means that every time you invoke a function, it returns exactly the same result for exactly the same input. Side effects make this false. There are many very useful patterns in programming that rely on having side effects and using side effects to... Okay, that stopped working completely. Not that completely. But one very interesting property of pure purity is that we can, the compiler, the language runtime can rearrange referentially transparent computation as it pleases without the programmer knowing or even caring. This makes for great speed up in the parallel computations without change in a single line of code. But that's not what we're going to have in JavaScript. Practical benefits of functional programming are largely those. I think that things like being able to prove that the code is correct or things like this are not very practical things. I mean, any sufficiently complicated program, and I mean any program more complicated than FizzBuzz will involve a proof that is many hundreds of pages long, and it's probably impossible for humans to follow. So it's I wouldn't say that it's very useful. Those are the things that I consider useful in the day-to-day practice of programming. First of all, as I hinted before, brevity and conciseness, which makes for shorter code, less code. Number of lines of code is not the greatest metric for anything, other than one special case. I didn't write down where, but in multiple studies, number of lines of code was directly linked to number of bugs in the system. It means that less lines of code, the shorter code is directly correlated with less bugs. Due to preference for immutability and purity, unit testing is much easier in functional style programs. There's no need for mocks, there's no need for complex setups, fixtures, and things like this. You just get the function and you call it with expected value and check its return value. That's all. There's nothing more. Functional programming, functional code is, I think, easier to follow than procedural, than imperative one, because it reflects the flow of data instead of flow of control in the program. That means that we're not distracted from what's actually happening, what actually the program does with its inputs. We're not distracted by control structures like loops and switches and things like this. These are largely hidden and given names, and you just look at them and read what they mean instead of looking at 15 lines of code and then inferring a structure out of it. Less opportunities to screw up, that's probably restating of the first point here on this slide. Or maybe I had something more in mind. Probably not. Okay. There are actually there's actually a very little things that the language, any language, has to support for it to be support a functional programming style. Those are the first two. Functions as first-class values, so functions that you can define anywhere, you can pass as arguments to other functions and return from functions and then do something with them. JavaScript, of course, has this property and it's used very widely. Lexical scoping and closures, that's not actually that hard of a requirement. I know of languages that are dynamically scoped and somewhat functional. The most used example is Emacs Lisp. But then you need to simulate closures via very heavy macrology, and I wouldn't recommend that. Tile recursion is completely optional because there's a pattern named trampoline, which should make it, which can make it possible to write naturally recursive functions without worrying about stack overflows. And then automatic queuing, that's named after Haskell query, so another Haskell reference in this talk. It doesn't need to be automatic. In JavaScript, with the help of many libraries, we get carrying, but it's manual. We need to call a function named mostly carry on the function we want to have carried, and then it is carried, and that's all. So not very hard requirements. Other than language support, there are things that environment or standard library need to offer to make functional programming viable. It wouldn't be very productive to write all those conveniences that would make functional programming productive from scratch. You would probably spend much time re-implementing the same things that many people already did. So when looking at functional programming environments like language and its library, or libraries that can be installed through NPM, we should search for a common higher order functions. So this is the name for functions that are called with functions as arguments and returning functions as their values. Those even made it to JavaScript proper with methods like map and filter, and probably for each even now. The libraries like Ramda, even very simple one like underscore, offers many more higher order functions to to work with both functions and the data types. We would need to have data types probably immutable, but that's not a hard requirement. It's just nice. By data types, I mean things like, among others, a queue, deck, or things like that. But the most important, of course, are collections like array or vector in Clojure, or list in Lisp. In JavaScript, it's array, and it's enough to work on arrays. One important thing about collections in functional programming is that all those collections need to share a very simple interface, so that all the functions that are defined for any one of those collections will work on the others. In JavaScript, that's not a great problem, because there's just one collection and one dictionary like hash map, so not very much ground to cover. Additionally, and this is where underscore fails very badly, those functions, higher order functions, and methods on data types and things like this should be designed from the get-go with composability and carrying, which is almost the same, in mind. There are right now, after a couple of years of I guess about 10 years even right now of work of different people on libraries, on functional programming libraries. We have very many of them. The one that we're probably all the best, we probably all know best is underscore, or its supposedly faster low-dash counterpart. It's actually, it supports, it's true, it supports functional programming to an extent, but otherwise it's very limited and basic in its capabilities. It's much better with the next generation of libraries that I listed in the next bullet point. Ramda is the newest one, I think. It gains traction right now. Prelude is it's not just for LiveScript, but it's bundled with this compiled JavaScript language. The others offer largely the same capabilities. They are complete in terms of features and functions they provide. There are also smaller in size libraries that are focused on function composition, on adding functions for composing other functions, which may be functions or maybe methods. The simplest function that falls into this category is bind, which we all should know. There are much more such functions which make it possible to, for example, create jQuery-like interface out of pure functions without having to resort to creating an object and prototype and whatnot. Then there are libraries for data structures. They largely do a good job. Mori is the oldest and the best supported. It's a part of ClojureScript and yields good performance. Immutable.js comes from Facebook and is only a couple months old, so I can't say very much about it. The rest are different libraries that focus on different things. For example, LZ library implements lazy streams and collections, and only those, which is nice if you frequently work with either streams of data or collections that are potentially infinite. One thing that requires to be mentioned here is that, the last project, Fantasyland, is appropriately named. It's about a world where we all agree on how to program, and it's a set. It's not a library, actually. It's a set of specifications of interfaces for the data structures and higher order abstractions like forbidden word and functors and arrows and things like that. For implementation with in JavaScript. Other than pure libraries, we have also compiled to JavaScript languages, which are a rather nice solution. I will tell why probably in a moment. There are different types of such languages. There are languages that are parts of existing languages, which makes them completely incompatible with browsers and JavaScript semantics, but at least they have some kind of community to support them and some amount of libraries already available. Then there are, I'd say they are experimental. Those are languages that are implemented on top of JavaScript, and they are completely new languages with implementing different interesting but not yet proven semantics and syntax. Elm is the language that I wanted to show you originally, but I think that needs to wait for the next talk. And my favorite are languages that preserve JavaScript semantics, but provide a syntactic support for many things that JavaScript makes hard or unnecessarily verbose. When I say syntactic support, I don't mean, and this is something I'd like to be quoted on, I don't mean a particular flavor of syntax. I'm not at all interested in semicolons versus white space sensitiveness versus begin, end, and such trivial matters. That's completely beside the point. What matters is that the syntax, whatever flavor it is, has syntactic constructs which support some of the features and functions, things that would be functions in pure JavaScript. Right. There are many, many more such languages in all the three categories. There's a list. I have no access to the internet. That's a list on the GitHub page of Jeremy Ashkenazis, the creator of CoffeeScript. It's growing every day, nearly every day. So the answer to this question is, well, it's simple. JavaScript is enough, but why should we make it so hard for us? JavaScript from the very beginning was not meant to be a fully featured language with comprehensive standard library with many opinionated choices on what construct it provides and what it makes possible and what it rejects. It's not Go. It's not a language like that. JavaScript is very flexible, and because of, or maybe as something that follows from the flexibility of the design, there is not many conveniences and default solutions included in the JavaScript D language. So we need to be productive. We need to have some support from some source, and while support from libraries is often enough, support from syntax is sometimes very nice to have. So for functional programming is, well, yes, JavaScript is enough to program functionally, but to program productively, functionally, in JavaScript you need at least a set of libraries and probably a way of extending the syntax of the language, which is quite easy, by the way. This is the same thing for object orientation. We have many languages that introduce the class or module keywords to the JavaScript. They are not strictly needed. We know how to declare a constructor and then use the prototype to add the methods to the instances of the class. I mean object, of course. Yet having this formalized in a keyword is even better than having it formalized in the method, and is even better than not having it formalized at all. Well, it's completely impossible for me to show you anything, any of the examples I prepared. I've been talking for 40 minutes now, and that's a bit long. I suspect you're going to fall asleep any moment now. I have those examples. I have no internet connection, so I won't show you. But I have those examples put up on the web with some rudimentary commentary on them in something like literate programming style. So after the talk, at the end of, probably at the end of here, or something like this, you can go to the link I post and look at those examples for yourselves. These are rather basic techniques implemented both in pure JavaScript and in LiveScript alongside it, so that you can see what is the difference between pure JavaScript without syntactic conveniences and a language that introduces at least some of the conveniences that make functional programming much more pleasant. So this, even if I showed you all the examples, that still would be not enough, not nearly enough. Functional programming is a vast topic with, okay, I think I did it. This word monads is here. Well, it's vast, it's huge a topic, and there are many different ways to use it. There are many interesting techniques that are actually established right now. There are also things like functional reactive programming, which are actually still a topic of ongoing research on of some very smart people somewhere. It's Connell Elliott, very smart people. It's functional reactive programming comes from Connell Elliott from the 2006 year, I think, or something. It's like 8 years old only. That's a list of very interesting introductory level materials that I'd it's well, I don't expect anyone to go through all of this in a time shorter than perhaps a year or something like this. Some of them, like the link to the video on YouTube, is only 30 minutes, but then it's so condensed that for every minute of this video you need to think 15 minutes and then start again because you realized you didn't understand it at all. So this is going to be for everyone who's not familiar already with functional way of solving problems. That's going to be one hell of a journey to master it. The Little Schemer, that's a book by Matthias Fellestein, which is one of the creators of very popular and powerful scheme implementation. Scheme is a dialect of Lisp, and but that's completely irrelevant because Little Schemer teaches concepts of recursion and function composition and all those interesting techniques that I didn't have the chance to show you in a very interesting manner with question and answer way. There's also JavaScript sort of translation of the Little Schemer made by Douglas Crockford. You can just Google it. For me, it wasn't the problem to translate the scheme syntax to JavaScript on the fly, but without some degree of familiarity with Lisp, that's not going to be very easy. It's not also that hard because examples in this book are kept simple and short and nice, but Douglas Crockford did a very nice job with this book, translating it into JavaScript. There are other books, full-sized books. There are articles, there are blogs. There is much of material and research to read and try to learn and then try to use. This is the very minimum of what I think you should read through to get a feeling of what functional programming really is. I will. The problem here is twofold. I have no internet connection, and I can't easily add a new link here. I will. Excuse me? Yeah.
We'll share all the presentations.
Exactly. I want. Oh, okay. That solves the problem completely. I will update this list with the examples I made and a couple of other resources after the presentation. Okay, so that's it. It took me a bit longer than I thought. It always does. Are there any questions?
Good. Thank you very much. Do we have any questions? We can take one or two.
What set of tools would you recommend for real-world use? Well, what tools are production ready and we can use them today?
Do you mean in the JavaScript?
In the functional world for JavaScript.
For JavaScript. I will go back to the list of libraries, and I'd say that any one of those in the second bullet point are production ready. Some of them are older and more mature than others, but nice thing is that they all share the same interface and the same specification. So that means that it's very easy to pinpoint bugs in their implementation and fix it if it needs to be fixed. Other than the libraries like these, and in the event that you don't want to invest in a totally different language like ClojureScript, actually I would recommend ClojureScript if you're familiar with or want to get familiar with Clojure and Lisps. I was a couple of months ago. I was on the PolyConf where one of the talks showed how to write a game actually in ClojureScript. It's so surprisingly easy and with no problems between getting the code from the editor to the browser and running it. So I think ClojureScript is totally production ready. But if you don't want to invest in those, FunScript is a F# implementation that it's also production ready and supported by Microsoft. JS of OCaml is from some French university and quite nice too. OPA is the language created by some startup from somewhere. it's a bit young still, but shows some promise. And Hacks as a platform that, other than providing tools for not only functional but programming in the JavaScript, also aim to support mobile development on iOS, on Android and Windows Phone, and probably on everything on Earth too. That is production ready. There are quite a few success stories about using Hacks, but that's again not JavaScript. So I would recommend one of I would recommend LiveScript. Well, I'm a bit of a committer to the LiveScript code, so I'm naturally biased, but LiveScript is now 1.3 version. It's stable. It implements everything I ever needed from language in terms of syntactic abstractions. In the examples I prepared, I showed most of them. It also implements features like generators that are coming to JavaScript right now. Most of all, LiveScript is mature. It doesn't change very often. It's considered feature complete until something comes to the JavaScript land that needs to be added to the LiveScript itself. That also means that there's not much going on the LiveScript mailing list and so on, because people are busy just using it and writing programs and discussing what to do with the language. Okay, so to summarize, one of those libraries, Ramda, looks good, and LiveScript if you want, or just JavaScript.
Thank you.
Thank you.